All right, here's a lesson on sampling methods. So we've already talked a little about errors that could happen in surveys and sampling. So in general, the best way to avoid bias when selecting a sample is to make sure that you have it randomly selected. So you're going to hear that a lot when we get into our internal assessments. Is it random and how is it random? This means that each member of the population has the same chance of being selected in the sample. So there are 5 types of sampling methods, and we will go more in detail in the rest of the video on those 5. So the first type of sample is called a simple sample. Suppose 3 students are to be sampled from a class of 30. The names of all the students in the class are placed into a barrel, and 3 names are drawn from that barrel. So each student has the same chance, 1/10 chance of being selected. Each set of 3 students is likely to be of any other. For example, Bruce, Jane, Sean, or it could be Jane, Peter, Vanessa. So a simple random sample of N population. So the definition is each member of the population has the same chance of being selected in that sample. Each set of N members of the population has the same chance of being selected at any time. So instead of drawing names from a barrel, it's sometimes possible to do a random number generator. And you can do these on computers too and on websites. But here's an example of a graphing calculator and doing the random number generator. So we'll get more in that when we get into class, but this is what it would look like with the graphing calculator screen. And you want to choose the 8th, 12th, and 25th students selected in that sample. So you would type in 1, 30, and then 3. All right. The next type of sampling is called systematic sampling. The sample is created by selecting members of the population at regular intervals. So for example, an accountancy firm may wish to sample the files of every 10 clients. So they choose a starting file from 1 to 10. So for example, they start with the number 3. Then they're going to go every 10 files after that. So they would select the 3rd file, the 13th, the 23rd, the 33rd, and so on. So that's an example of a systematic sampling. Example 1 in your book. The management of a large city store wishes to find out whether potential customers like the look of a new product. They decide to sample 5% of the customers using a systematic sample. Show how this would be selected. So 5% or 5 out of 100, which reduces to 1/20th. So every 20th customer would be sampled. So starting a customer is selected from 1 to 20. In this case, the calculator shoots out 7. So then you're going to choose the 7th, the 27th, the 47th, the 67th, and so on. And again, we'll do this in class with the graphing calculator. The next type is called the convenience sampling. In many situations, people are chosen simply because they're easier to select or more likely to respond. For example, consider research conducting a survey regarding environmental issues. The research decides to stand in a pedestrian mall and ask people walking past. It's easiest for the researcher to ask people who are walking close to them, walking slowly, not already in a conversation or using the phone. These types of samples are known as convenient samples because they're convenient for the experimenter who's collecting the data. Next one, stratified sampling and quota sampling. Oops, sorry about that. Stratified sampling and quota sampling are useful when the population can be divided into subgroups, and you want to make sure each subgroup is represented fairly. For example, school may want to know the opinions of its students on which are charities it should support in the school fund run. To make sure each level is represented fairly, the number of students sampled from each level should be proportional to the fraction. So you have year 8, year 9, year 10, year 11, and year 12, and then you have your samples. So here's an example. In our school, there are 137 students in grade 8, 152 students in year 9, 174 in 10th grade, 168 in 11th grade, and 121 in 12th grade. A sample of 50 students is needed. How many should be randomly selected from each year? So you want to go ahead and add up all of the students. So there are 752 students in the school. Then you want to divide 137 by the total and then multiply it by 50. So what you're going to do is you're going to approximately sample 9 students in year 8. And you would continue that for year 9, 10, 11, and 12. And that'll tell you how many you should randomly select. Ideally, we'd want the individuals from each strata to be randomly selected to minimize bias. So you wouldn't want to ask all your friends. This can be done, the sample stratified sample. Otherwise, if the individuals are specifically selected by the experimenter, such as its convenience, then it is a quota sample.